Hey, I'm Jesse Whiting from Ghostwire Audio, and this is day one of MicroDSP. So let's kick off the series with the smallest DSP project imaginable, generating a 440Hz tone from scratch with C++ and exporting to a WAV file. The whole thing is basically just a simple math problem. First, we're going to need our basic audio components. In this case, we're going to use a sample rate of 44.1 kHz, a duration of 2 seconds, and a frequency of 440Hz, which is A4. Then we'll need to figure out how many samples we need. Sample rate is measured in samples per second, so we can just multiply our sample rate by the duration, which tells us how many little dots we're going to generate. Now the fun part is actually generating the sine wave. For each sample, we're going to plug t into the equation sine of 2 pi ft. In this case, f represents frequency, and therefore 2 pi f represents the angular frequency, which converts cycles per second to radians per second, which essentially describes how fast a wave oscillates over one full cycle. We then multiply by t, which represents time, to get the sample value at that time. This gives us a value between -1 and +1. But WAV files don't store floating point values, they store integers, 16-bit integers to be exact, so we're going to need to scale up to the full 16-bit range. WAV files are also picky. You have to build a specific header so the media players know what they're looking at. This will contain file size format, data size, sample rate, all the fancy byte level stuff. Once the header is written, we pour the samples into binary, and boom, we've synthesized a real audio file using nothing but math and raw bytes. This is the foundation for literally every audio project ever. Once you've got this down, you can start moving on to filters, oscillation envelopes, distortion, anything. If you want to see every line explained, the project is on GitHub with extensive commenting, which you can check out in my bio. And yeah, that concludes day one. See you soon.